Okay, today's topic is space, and in particular, whether space might be the future of agriculture and biology. And we will explore exciting topics like growing plant cells in space. And to help me with this conversation, I am joined today by Chris Hatfield, who is a Canadian astronaut who has flown 2 space shuttle missions and served as a commander of the International Space Station. Hi, Chris.
Hello, Bernard. How are you?
I'm really good. I'm really looking forward to this. And we have Ilan Sobel, who is the CEO of Bioharvest. How are you?
It's a pleasure to be on the show with you and having this discussion on a very intriguing topic.
Absolutely. So where are you both joining us from today?
I'm joining from Tel Aviv, Israel.
Excellent.
And I'm joining from Toronto in Canada.
Very good. We're spanning the globe pretty much. I'm just north of London. So maybe, Chris, we can start with you and this is my first time speaking to a real world astronaut. This is super exciting. Maybe you can give us a bit of background of how you ended up becoming an astronaut.
I decided to be an astronaut when I was 9 years old.
Wow.
You don't just randomly become an astronaut, I don't think. So when I watched the first people walk on the moon, I was just about to turn 10. And I thought, that's the coolest thing that a human being can do. Why don't I do that? And so then it was a matter of changing who I was and gaining the skills and trying to be the type of person that might be trusted someday to fly a spaceship. And amazingly enough, after being an engineer and a Cold War fighter pilot and then a test pilot, after all of those things, I got selected as one of Canada's astronauts. And I served 21 years as an astronaut and flew in space 3 times and helped build 2 space stations and then commanded the International Space Station. So I have to pinch myself that these are things that have actually happened in my life. But you mentioned we span the world today. In truth, I've been around the world 2,650 times, which sounds bizarre, but it really gives you an interesting, clear understanding of our planet as a place, a small and precious place in the universe.
So what's your most memorable experience as an astronaut?
Walking in space. If you ever get the chance, Bernard, walk in space. To put on the big white spacesuit and open up the hatch and physically pull yourself out into the universe, and then to be so incredibly tiny next to that gigantic, silent, omnipresent world beside you, but to be out, in the 3-dimensional eternity of the universe, and yet at the same time to be there and to see it and to experience it. I mean, you have a million things to do when you're out on a spacewalk, building things and fixing things, but just at a personal level, it is. I was outside twice, total of about 15 hours, so 10 times around the world, and that is the most thought-provoking and impactful and interesting 15 hours of my life, I'm sure.
Unbelievable. Yeah, amazing. And Ilan, do you want to do the same? Give us a bit of your background and how you became CEO of Bioharvest.
I thought you were asking me if I wanted to actually be an astronaut and go on a spacewalk like Chris. So absolutely. What an amazing lifetime experience. So Bernard, I'm the CEO of Bioharvest Sciences. I have the privilege of this role. My path to CEO is not as unique as Chris's path to being an astronaut. Basically, my background: I spent 18 years as a senior executive of the Coca-Cola Company internationally, and then I spent another 6 years co-founding a big data, IoT, and software company, and actually was very fortunate to be part of an exit to a major multinational. And I actually came initially to Bioharvest Sciences as an investor. And when I saw the unique platform technology that Bioharvest Sciences has, just given my background in the food and beverage industry, I realized that they had a platform technology that could really change the world. And in a nutshell, the company has a platform technology that's able to bring the power of the plant to the people. And what the platform technology can do, it can take any primary metabolite, which is like a protein, or a secondary metabolite like a polyphenol, an antioxidant, or even cannabinoids that are found in plants. And we're able to take these critical active ingredients that are so important for our overall health and wellness, and we're able to grow these active ingredients in cells in a way where we do not in any way change the molecular structure of the active ingredients. So it's non-GMO, and we grow these cells in bioreactors in aseptic environment over normally a 3-week process, and we're left with an amazingly soluble and bioavailable end product that has fantastic efficacy. We've done this today and validated our platform with red grape cells, demonstrating the power of the French paradox, which is all about improving overall cardiovascular health. We've also done it with olive cells, which is bringing the benefits of the Mediterranean diet to life, which is all around reducing LDL cholesterol and improving HDL cholesterol, as well as in the pomegranate space. Pomegranate cells, which is about reducing inflammation. And then our claim to fame, Bernard, right now, in addition, as part of our prize to be the global leader of plant cell biology, is that we're the only company in the world that's actually able to grow full spectrum non-GMO cannabis without growing the plant. Because we grow the cells of the cannabis plant, we take the plant once, we grow the cells, and then we actually grow trichomes, which are the mini factories that produce the cannabinoids in our bioreactors. And this gives us an amazingly consistent and aseptically clean product that we will be bringing.
Very good. And so, Chris, how did you get involved with Bioharvest? Because people might be wondering what your role is in maybe using space to grow things in the future.
Bernard, we're at a really interesting moment in space history, in that we've been flying in space for 60 years, since Gagarin and Al Shepard flew. But it used to be so incredibly dangerous and complicated that only the biggest nation in the world could afford to do it. But with recent advances in rocketry, the cost has come down by multiple orders of magnitude. What used to be, $25,000 a pound or something on the shuttle is now 100 times cheaper than that, and about to be 1,000 times cheaper. So when you radically drop the cost of transport, whether it's airplanes or cars or whatever, it opens up all sorts of new possibilities. And that's where we are in space travel right now, in space access. And so what it means is not just a few select lifelong trained astronauts like myself, but a lot of people are going to be living on space stations around the world and starting to settle on the surface of the moon. So NASA and all the space agencies, European and Canadian, are working on a thing called the Deep Space Food Challenge. How do you feed people when you're living away from the world for a long time? Do you just ship everything in, little tins and cans of stuff, or dehydrated or thermostabilized? Obviously, that'll work for a while, but you want to cut the apron strings. You want to cut the strings with Earth if you can. And so being able to grow things either on board a spaceship or on the surface of the moon, that's where eventually we will get to. And so we're looking for technologies with the Deep Space Food Challenge, all sorts of companies around the world. And Elon first came to me, I don't know, a year ago or more.
Yeah, about a year ago.
And let me know about this technology. And this biotechnology, just using sort of a way to grow the key part of a plant, but without having to have fields and sun and dirt and bugs and all the rest of it, that miniaturizes itself really well, and it's scalable. And so I thought this has tremendous application here, not just in space, but of course on Earth, where if we're trying to feed, what are we going to peak out at, 10 billion people? We can't just have agriculture like we had it 6,000 years ago. We need more efficient methods, and not just GMOs and fertilizers and pesticides, but maybe some other way to produce part of our food. So to me, it's a really sweet spot. We're exploring and settling in space like we never have before. Our technology's gotten a lot better. We have a new need. And then here on Earth, we have an overwhelming need for better ways to produce food for all of the people and raise the standard of living. And so this type of technology interested me. I was really keen to see it. I had a chance to go to Tel Aviv and go through their science laboratory, talk to their scientists who've been working on this for over a decade, and then to see the new production facility where they're scaling up. And I love being in on the start of things. Astronauts love launches, and so to see this launching and to be able to advise them and maybe get some of this technology up being tested on the space station, so then we can use it later. That's my path to be here, and it's cleared for launch right now. It's coming along really well.
Yeah, and I couldn't agree more. We need biotech to help us solve the problems on our own little planet, let alone once we move into space. So, Elon, why is space then the next frontier for Bioharvest?
Well, there's a number of different use cases. I think I just want to reference back to your point you just made about, how do we actually help solve some of the major challenges we have here on Earth? Well, in fact, space actually gives us, in many respects, that opportunity, because in space, we're dealing with a microgravity environment. And that's where a lot of the experiments are happening today on the International Space Station, where companies like ourselves understand that the secondary metabolites that we grow, for example, in our cells, under a microgravity environment, they may actually grow in different ways, which could in fact have a significant utility value when we bring this back to Earth. And, as Chris talked about, the way that, the space race has changed the whole world from an economics perspective, in the next 5 to 10 years, we're going to have space commercial stations where companies will be actually growing and manufacturing different products in space. And under a microgravity environment, those products are creating very unique, call it medicinal compositions, and then bringing them back to Earth in order to better treat people from an overall health and wellness perspective. So our first product that we are looking and working together with a partner, Space Tango, who's a middleware partner, and working together with them with the vision in the next 12 to 18 months of actually starting our first experiment on the International Space Station, is taking our red grape cell product, which has very unique polyphenols, which is based, as I said earlier, based on the French paradox, where we have piceid resveratrol. We're the only company in the world that can produce piceid resveratrol from the skin of the red grape. And in combination with other polyphenols, we've been able to demonstrate in clinical trials the ability to significantly increase flow-mediated dilation, which really results in increasing blood flow in the body. And this is so super important for the functioning of our body. So the idea is, okay, let's go and actually grow in bioreactors in a microgravity environment these same red grape cells, and let's understand then what kind of composition of polyphenols will we get. Maybe we'll get a very unique composition of polyphenols that will have a specific additional use case, bringing it back to Earth, that we could use in order to make a dramatic transformational improvement in the end user's health and wellness. So this is the new cycle that companies from a thought on the edge, from a thought leadership perspective and a technology perspective, are looking to leverage the power of the microgravity environment and bring the benefits back to Mother Earth.
Very good, Chris. So what's the typical diet of an astronaut, and do you feel that this effort could supplement this diet in the future?
It's sort of like sailing vessels 500 years ago. When Magellan launched with his 5 ships in the early 1500s out of Portugal and Spain, 5 ships, 250 people on the very first effort to go around the world. I've been around the world 2,600 times. They were just trying to get around once for the first time. But it took 3 years and only 1 ship made it. And Magellan himself was killed and only 15 people made it back. And everybody got scurvy and they had all of their canned and tinned foods with them. So that was early exploration where they really didn't have a lot of science going for them. It took 200 years before we figured out how to defeat scurvy on a circumnavigation of the world with Captain Cook and his Botany Bay and all of that research. And onboard spaceships, we're still sort of in the early days. We bring all our food with us, primarily in cans and military rations and stuff. And we're only starting to grow things in just a very experimental way, just to see how things can be grown with simple things, tomatoes and lettuce and cress and simple flowers and things like that. So when it's food time on the space station, typically you go into the pantry, you pull out some little prepackaged thing that says on the outside, mashed potatoes, and it feels like a lump of clay. And then you slide it over a little needle, and it tells you how many milliliters, and you can choose lukewarm or hot. And normally with potatoes, you'd choose hot, and then it puts in the right amount of liquid, and then you knead it and squish it, and then you get a set of scissors and you cut it open, and then you eat your relatively disgusting reconstituted mashed potatoes that who knows where and when that was ever packaged up. And a lot of our food, I mean, it's healthy, it's fine, but it's not a sustainable way for us to feed ourselves. If you really want to have settlement for long-term in space, and Elon talked about the ability to do research up there. We're in the process of developing 4 commercial space stations right now, funded by NASA and private research. So we're running about 200 or 300 experiments right now on. Just a sec, I got dogs behind me. Hey guys, come on, out, come on, out you go. They're fighting over a stuffed toy. So up on the space station right now, we run about 200 experiments simultaneously. And some of them, are looking at the very substance of the universe itself. And a lot of them are studying the Earth, but a lot of them are based on human health. And some of them are how to grow foodstuffs in a sustainable way for us up there. And so this fits into that piece. How can we create the things that we need with as little energy and space as possible, in order to not have to be reliant on a supply chain back to Earth all the time. And so this is a real sweet spot in history, but also in technology. And especially if you can make it super efficient. And as Elon says, what we come up with there may not just be applicable to astronauts, but we'll be learning some things that will be applicable back to the process on Earth. And meanwhile, this biotech platform is creating at scale for the Earth market also. So it's an interesting moment, but there's definitely a need as we get further and further from the surface of the Earth.
Interesting. So, what was your favorite food on the space station?
One of the biggest differences, Elon called it microgravity. That just means 1/1,000,000th of the gravity that we experience on Earth, because there's tiny little accelerations on a ship, a little bit of pull from the moon, a little bit of pull from the sun, from Jupiter. But basically you're weightless. So if you're weightless, then there's nothing pushing the blood down to your feet, and there's nothing draining your sinuses. And so if you want to know what it's like to eat food on a spaceship, here's what you should do, Bernard. You should stand on your head for about 3 hours. Just stand on your head for 3 hours, and your sinuses will fill up, and your eyes will swell a little bit, and your tongue will swell up. And then while you're upside down after 3 hours, then eat food. And it's sort of like when you have a bad cold, a lot of your taste is suppressed. You don't get the tanginess of the food because your sinuses are full and your tongue is swollen. So as a result, I like the spicy food better up there. And oddly enough, one of our spiciest foods was the cocktail sauce, which has horseradish in it, that goes along with shrimp cocktail. And dehydrated shrimp cocktail, it rehydrates reasonably well, so that when you bite into one of those rehydrated shrimps, it's still got some texture to it. So that mixture of reasonable texture and a nice sort of sinus clearing sauce, oddly enough, my favorite food in space was dehydrated shrimp cocktail.
Excellent. Yeah, I recently read that you don't really smell your food either in space. So I think NASA was working on your ability to drink coffee, because coffee is so much about smell, and they designed a new device that actually disperses some of the molecules into the air so you can smell them.
Well, imagine if every time you wanted a coffee, you had to go to the pantry and then flick through 500 little packets. So one says, black, and one says 1 cream, 2 sugars, and one says, sweetener, and you go through all, you find, oh, here's the one I wanted, 2 sugars, 1 milk, or whatever. And it's just powder. And then you plug that into the wall and it fills it up with hot water, but not super hot. And now you've got this, and you mix it up, but it's got a straw with an on-off valve. So you put this straw in your mouth and you open up the valve, and now you suck this liquid in, and so it's not very good coffee. And because of that process, imagine drinking coffee if you never smelled it. It gets rid of a whole bunch of the experience. So yeah, you're right. They were working on some way to get the smell into the room of the food, but it's more complicated than it seems. And we're still only partway there, and it's not the main purpose of being there, but it is psychologically important. And I think occasionally you can make the space station smell like a barista is there, but not normally.
Very good. So, Ilan, you talked about this bioharvesting process and that we are already using this on Earth. So how does it work in practice? Anyone that isn't an expert in biotech, how would you just explain to anyone how this process works?
So it's pretty simple, and I'll use it. I'll use our Vinea product that we sell in the marketplace in North America as an example. So Vinea is based on the French paradox. French paradox, as many people may know, is based on the fact that the French people have a very fatty diet, but they have very, very good cardiovascular health. And the scientists went to understand exactly what it was that was giving them the excellent cardiovascular health. They realized it was from literally moderate consumption of red wine. Bernard, that means 2 to 3 glasses of red wine every single day. And when they went deeper to understand exactly what was it inside the red wine, they realized it was a combination of polyphenols. Specifically one polyphenol called piceid resveratrol, and then a matrix of other polyphenols that work together with the piceid resveratrol, including catechin, quercetin, anthocyanins, and tannins. So what we do is we start with the plant or the fruit. So we started with the red grape. We took cells from the different parts of the actual red grape, from the skin, from the flesh, from the seed, and we grow these cells in solid media in a petri dish. And we feed the cells a unique batch of nutrients in order to grow. And then we move it into basically a small bioreactor, then into medium bioreactors, and then into large industrial-sized bioreactors. And in these large industrial-sized bioreactors, you can imagine a bioreactor the size of me. I'm 6'2" tall. I'm, let's call it maybe, think about a meter wide. And in these unique structures, we grow the cells, and over 21 days, we do what nature pretty much does in literally 18 months, even up to 2 years. Because ultimately, what we're doing is we're growing these specific red grape cells, and we're growing the unique polyphenols that I've talked about up until they reach a certain body mass, and then we literally, like wine, we harvest the cells and we dry the cells. And we're left with an amazingly rich, soluble, and bioavailable powder that we put in a capsule. And inside this capsule, in each capsule, you have the same amount of piceid resveratrol that's contained in 1 bottle of red wine, but there's no sugar and there's no calories. So for example, in our clinical trials, we demonstrated that, after taking 1 capsule every single day for 3 months, we were able to increase the flow-mediated dilation of your arteries, so increasing the blood flow by up to 70% versus baseline. And this obviously is so important for the functioning of the body. So this is the process we go through. We do this with olive cells. We do this also with pomegranate cells. These are 2 products that we're going to bring to the market in the future. And as I said earlier, we also have the unique ability of being able to do this with the cannabis plant, and to be able to actually bring to the marketplace unique full spectrum cannabis, non-GMO. There's no genetic modification in our process. It's full spectrum. And we're able to produce these critical active ingredients through our cells in a way which has fingerprint consistency, which is so important from an overall medicinal perspective. We have unique cleanliness. And then importantly, we do this with environmental sustainability credentials that are unique for the industry. Obviously we're utilizing a tiny fractional footprint from an overall land perspective. The amount of electricity that we're utilizing and the carbon emissions are a fraction of what similar industries are utilizing. And because we're growing ourselves in an aseptic environment, and we're not utilizing fertilizer and other elements, all the water is 100% biodegradable. So it goes back into the water system. So it's we're doing the right thing in producing an amazing product that has unique efficacy from a health and wellness perspective. And we're doing it in a way that's leaving the planet in a better way for our children and our grandchildren. And that's really the ethos of who we are as a biotech company. We're purpose-driven. We have this amazing platform technology that goes across, multiple different verticals. And we're bringing this to market now and really fundamentally improving people's lives based on the different areas from a health and wellness perspective that we're making a big impact.
Very good. So, Chris, how do you see this fitting into the larger space initiatives such as research, missions, tourist flights, and potentially even future settlements in space?
Sure. Well, there's a key number that Elon didn't mention, and that is one of those bioreactors, one of those Elon-sized bioreactors is the equivalent of about 240,000 square meters of a field. If you were looking at grapes or pomegranates growing in a field. So
spot on.
Yeah. So if you're looking at Earth application, of course, we need that. There's only so much arable land, but there's even less arable land on the moon. And every space agency in the world, and over 70 countries have their own space agency right now. And all of them are recognizing that this is the moment in history where our technology is good enough that it's now becoming not just technically, but financially feasible to start settling somewhere besides Earth and Earth orbit. All of, NASA and the European Space Agency and the Chinese Space Agency and everybody around the world. And so one of the problems that we have to solve in order to settle somewhere is, like all the people that live in Antarctica, how do you feed them while they're there? And technologies like this one are key. And so I'm confident that as we start with the people, not just settling on the space stations where we've been living for over the last 20 years, but when we're further away on the moon and beyond, we will have ways of producing food that are different than we've done for the last 6,000 years on Earth. And this is going to be one of them. You're going to go into the food production facility, and there will be a bioreactor in there or several of them producing different things that we need to stay healthy. And it's going to happen. That's the natural logical progression. But we're in the proof of concept stage right now, both here on the surface, but also testing it up on the International Space Station. So it's fun to be involved in that. As a kid, I was fascinated by the astronauts going to the moon. I flew in space 3 times, and now to be working with companies that are enabling us to not just barely get to the moon, but actually start to stay there for long periods and set up permanent settlements and do it in a healthy, sustainable way. To me, it's a lovely pattern of life to have been involved in all this. I'm really excited to be able to support this right now.
Absolutely. And we talked about this earlier, that part of eating is this experience, is all your senses being involved in all of this. And Ilian, you were talking about at the moment you produce a little pill, a supplement that you take, which is not the most exciting experience you can have. Looking into the future of food, I get really excited when you combine some of the technology that you're using with things like 3D printing to actually produce personalized real food. Is this a vision that you see in the future?
Look, I think the whole area of personalized food based on people's overall health and wellness credentials is a vision that the world will get to potentially in our years of life on this planet. At the same time, you're seeing such disruption in technologies today where, Chris talked about space settlements and the need that you can only take so much canned food, only so much canned tuna up to a space settlement. You've got to take other use your scarce space for other critical elements to take up to those settlements. So one of the areas that our technology is able to do, and it's something that we will focus on in the future, is, I talked about secondary metabolites like polyphenols and antioxidants, but we're also able to produce primary metabolites like protein. Obviously, protein is critical from a food perspective. And we believe we're able to actually produce protein that has all the amino acids. So, Chris talked about going in space, and you have to, in order to get all your amino acids, you've got to choose multiple different veggies, and different components to get all your amino acids. The ability to actually, be on a settlement, have bioreactors producing protein that has all the amino acids inside it, really brings a unique level of nutrition to those people on the space settlement, but also a level of efficiency, which is so important when you're dealing with those kind of environments. So, whether it's personalized medicine or whether it's actually, leveraging the power of nutrition and making sure that you're combining all elements of nutrition into one unique proposition that's grown in a unique way. This is where, the world of food tech and biotech is starting to converge, and it will converge here on planet Earth, but it also has the opportunity of converging for different reasons in space settlements.
Very good. Chris, same question to you about 3D printing of food. I know you're already using 3D printing technology on the space station, right?
We've used it for a lot of sort of mechanical things where you can print a tool. Like if you need a certain tool, you can make it out of the liquids that go into 3D printers. But we've also been 3D printing like tissue, human organs, because if you're trying to, on Earth, 3D print, say, I don't know, a kidney or a heart, it's so complicated because the tiny little filaments and blood vessels and things in there, as they're being printed, they tend to collapse under their own weight. And it's really complex to try and build a 3D structure like that. But if you're weightless, essentially, then you can 3D print something that is far more tenuous. And there's a lot of research being done on that right now. But there are also a lot of companies on Earth that are looking for alternate ways to create all of the different types of food that we eat. You can go into a fast food joint and get Beyond Meat now, but there's people that are looking at 3D printing the protein into some sort of more familiar form, something that has the texture and the flavor and the familiarity of it, so that it's more palatable to people. And you've got to start somewhere. And we're in the early stages of a lot of this. But to me, that's inevitably where we're heading. We can't just do it like they did in the, in the Fertile Crescent back thousands of years ago, when we try and scale to the whole surface of the world or to other worlds. And so taking all the things we've invented, but doing it in a natural way, not artificial, but where these things are growing as a natural plant, and then modifying those so that they can turn into familiar looking food and stuff you can chew and taste and smell. That's where we're going to end up with it. And so that's a pretty exciting time, but we've got to invent it. We have to test it. We have to prove it. We have to market it, and then learn from that and move forward.
Very good. So beyond 3D printing, what other cool technology were you using on the space station that really got you excited? Gosh,
the 200 experiments we're running up there, it's amazing. The thing that gets me the most excited is understanding the world better. The space station goes around the world 16 times a day. And we've been doing that every single day for 21 years. So our collective accurate understanding of the actual state of the world is better than it's ever been, for how things work and how this whole closed system functions. You don't have to just guess what's happening on the other side of the world. So global awareness, that's a huge benefit of what we're learning from the space station. We're also collecting particles that are smaller than atoms, subatomic particles, the muons and the leptons and the bosons and things, because we don't even know what 94% of the universe is made of. We can only account for 6%. of the universe. We call the rest of it dark matter and dark energy. We could have called it anything. We don't know what it is. So that's that type of research. Although it may sound very scientific to me, that's so important to try and understand what causes gravity, and is there any way to harness that? And if we ever want to wean ourselves off fossil fuels, we have to dig into the very nature of atoms themselves. So there's a huge suite of experiments going on up there. How does fire behave when heat doesn't rise? And we learned a whole new area of flame and flame extinguishing, which has applications, and how do fluids behave? And it's just an amazing laboratory to live in, and to push the edge of what we understand, as well as a place to occasionally get to smell the coffee.
Very good. So Ilan, how soon do you think the bioharvesting technology could be in orbit?
Well, as Chris said, it's a process, and we're working with our partner Space Tango. We have to modify the bioreactors. So obviously, we have very unique proprietary bioreactors that we utilize to grow our cells, and we've got to understand exactly how do we best adapt those bioreactors to the conditions that they are in the space station itself. This takes time. It takes testing. It takes learning. I think realistically, within 12 to 18 months, we would. Our vision is to have an experiment to actually take place on the International Space Station. Those kind of experiments today are becoming a lot more accessible, as Chris said, because of the space race and because there's just so much going on that the overall costs of entry, barriers to entry have dropped significantly. And that really allows, companies like ourselves that are on the forefront of science on Earth, on the terrestrial environment, to make sure that we continue to push scientific frontiers by leveraging the power of zero gravity or microgravity environments on the International Space Station, to be able to understand how our technology will be adapted by that kind of environment. And in many cases, those changes are positive changes that can really have a significant positive impact for the astronauts actually in space, as well as people who are, basically suffering from, challenges from a health and wellness perspective here on Earth. And, one example is that our Vinia product, we've been able to demonstrate that it's able to reduce the oxidation of LDL cholesterol. And this is actually something I learned from Chris during one of our conversations. And I realized that oxidation of LDL cholesterol is one of the biggest challenges for astronauts when they're in a microgravity environment. So we're super keen to understand, okay, when we actually grow our cells in a microgravity environment, to what extent can the new primary metabolite structure or the structure of the polyphenols, to what extent will that further help address the big challenge that astronauts have as it relates to the oxidation of LDL cholesterol, because that starts to form plaque in their arteries, and is obviously something that they monitor very, very carefully when they're spending long periods of time in space. So it's a very exciting time for companies like ourselves. It's a huge privilege to be able to work with people like Chris, who have the tremendous experience in space, but also have an amazing engineering brain to be able to help us understand how best to adapt the technology, working with partners like Space Tango, to be able to make sure we get that impact from the time that we're spending on those experiments, and then we're able to leverage that utility value in space as well as bring it back to Mother Earth.
Very good. And are you planning to work with other well-known space companies like SpaceX, for example, in the future?
Because of the space race, there are a lot more opportunities for us. In the past, you would have, NASA. Now, as Chris said, you have multiple different countries that have their own, call it space ecosystems. You've also got the private ecosystems with the space race with, Branson, Bezos and Elon Musk. And that's amazing for companies like us, because they're bringing space so much closer to us to be able to do these unique experiments, which ultimately are experiments that are going to be able to drive biological breakthroughs for the world. And I think that's super exciting for companies that are at the forefront from a biotechnology perspective, because we live and breathe based on building human utility value, which is about driving a transformational change in people's overall health and wellness. And if understanding the power of a microgravity, zero gravity environment, by understanding the power of that environment on actually modifying our unique metabolites that we're growing in space, and how we can then leverage it in Earth, this is a game changer for humanity in many respects.
Very good. So, Chris, what would you say are your hopes and predictions for the future of agriculture and maybe the future of space as well?
Well, when I was born, no one had ever flown in space. We tend to be, I think, a little frustrated because things don't go as fast as science fiction or as fast as we imagine or something. But if you just have a slightly larger view, we've only been traveling in space for a very short period of human history. And we've gone from just barely capable, where people were willing to risk their lives at a tremendously high level of failure, to now people living and working in space internationally for decades at a time, with 15 nations of the world working together. So if you look at that arc, and it's never been easy, and there's always current problems that threaten it, but it has been happening for the last 30 years. And the technology has steadily gotten better. So, if you extrapolate that forwards, then I think it's going to be relatively predictable. The Earth orbit economic system is going to become more complex, more regulated, more integrated, and we will regularly be having companies and people and all sorts of experiments and communications devices launching and helping to serve us here on the surface of the Earth. And company or organizations like NASA, they will then be freed up to do the further exploring and to open up the frontiers of the surface of the moon and beyond. The moon, if you were to lay it out on a map, it's bigger than Africa. Imagine if we had just discovered a continent bigger than Africa, of unlimited geology. What would we do with it with no life on it? It's a tremendous, not just exploration, but tremendous opportunity just for increased human capability. Just the geology, the geologic wealth of it alone. And so that's where we're headed next. To the surface of the moon for a generation or so, inventing and testing and expanding the human experience, an Earth-Moon economic system. And then once we've learned and developed things there, then we'll be able to go across the huge ocean of space that's between us and Mars. And that'll be the destination after that. And it's a relatively representative history of humanity, starting in one place, developing technology, moving around the surface of the world. 60 years ago, for the first time, starting to go vertical above our atmosphere, living on a space station for 20 years, and next moon, Mars after that. That's where we are in the history of our species. And technologies like what Bioharvest is creating, they're going to be feeding us as we take that voyage.
Very good. And Elon, what are your hopes and predictions for the future of agriculture, biotech, and maybe space, if you have anything to add?
Look, we're living in a very exciting time when you're actually seeing a unique fusion of biotech, food tech, and sustainability. I think, there's companies around the world like ourselves that are able to really hit the sweet spot, where you're able to bring, critical health and wellness today. After what we've all experienced in the last 2 years, health and wellness is at the forefront of every single person as a result of, the COVID epidemic. And people are looking for better health and wellness solutions all the time. Food companies are understanding clearly that it's not just good enough to produce what they're producing. They've got to continue to push themselves in order to bring better health and wellness credentials to the actual food items that they're providing the world today. And then at the same time, we're realizing that when we do this, we've got to do this in a way that's preserving the planet and is leaving the planet to in a much better way for our children and grandchildren. So I think this is an exciting time where you have all these forces all working together, we have the technology, we have the awareness from an overall environmental sustainability perspective. And it's those companies that are pushing the edge from a technology perspective that are going to really craft very unique leadership highways of really changing the way of health and wellness and nutrition in the world in a way that we're giving unique health and wellness benefits to consumers, whether it's in a food nutrition or whether it's in a botanical drug route, but in ways that are making sure that we're leaving this planet Earth in a condition that we can all be proud of and can preserve for many, many generations to come and beyond.
Very good. Wonderful. Chris, anything to add?
I think, especially in tumultuous times, it's good to raise your eyes above the horizon. The psychological, not just the health impact, but the psychological impact of the COVID pandemic has been hard on our species all around the planet. And it becomes and the conflicts that go on around the world, the incredibly wicked disagreements that we get up to over territorial rights or things like that. Meanwhile, there are magnificent things happening, magnificent human behaviors, things that we can all be inspired by. And you can sometimes lose sight of them. But the fact that we have a human creation orbiting the world 16 times a day, that was done even though there have been conflicts, but still at the same time done cooperatively. And every single day, 24 hours a day, 15 nations of the world for 3 decades working together to make this possible. And any person on the world can walk outside at dusk or dawn and watch it go overhead, watch the international. It's the third brightest thing in the sky after the sun and then the moon. The third brightest thing is the space station reflecting the light up there. And I think that type of inspiration, in amongst everything else that's happening in the world, is not only healthy for all of us, but it's really necessary. And I'm pleased that it's not just symbolic, but it's also an amazing scientific research station for all of us.
Very good. I found this so hugely inspiring. This conversation is inspiring in terms of the future of humanity. We're talking about sustainability, some of the most important topics. So thank you so much for your time. I really, really enjoyed this today.
Lovely to meet you and to speak with you as well.
Thank you. And anyone who ever wants to re-watch this conversation, head to my YouTube channel where you can watch this and many other exciting conversations. So thank you very much.
Thank you.
Thanks for the opportunity.